In this exercise, I have learned the deep learning using neural network. I have used Keras and TensorFlow for this exercise. So the requirement was to use the dataset that was provided by our instructor from the last exercise, uh, and then using that text file, that's a text file of Twitter, texts with some sentiment analysis, preliminary sentiment analysis. So the task was using that text file, we have to determine the sentiment of the texts. For that, actually, we need to do the data reduction, data cleanup, then modeling using the Keras neural network framework, then train the model, test the model, and finally predict the result from using that model. So let's go to the code base. I'm going through step by step. So in the first step, I imported the required modules uh, and then extract the data. Let's see what is there. And this is a NumPy array, and you can see each row of the Twitter data, but you can also see that I have done some data reduction. That is, we no longer have those index, I mean all the 4 columns, we just have 2 columns. These columns, the first one is the sentiment, and the second column is the Twitter text. So uh, now we have to create the training data. So in order to create the training data, what we have done is as follows. We basically define the training data in this way, train X and train Y, and then we tokenize using the Keras tokenizer library. And here we get rid of all the punctuations, the Twitter handles, all the unnecessary stuff for this analysis. We converted everything to lowercase, all the letters to lowercase, and then we got rid of the spaces, and that way we generate the word index. In this way we are creating the index. So once we create the index, we go to the next level. Now here I followed some of the examples for data processing. They say it's a best practice. I also agree with that, because if I save the dictionary.json, then I don't have to go through all the initial step all the times if I change my code, so I can use these dictionary files once generated. I created a utility method, and that actually is important. That method is important because um, it it makes all the text this with the same length, and then we define the train X and train Y. This is the cleaned up data with train X, which is the actual Twitter data, and train Y is the model, is the sentiment. So these two pieces of data we are feeding into the system. So let's run this part. So now comes the model. We have used the sequential model, Keras sequential neural network. It's the simplest type of neural network, simple type of neural network, in a sense that we don't have to write in neural network specific code by ourselves. We can take advantage of the existing model coded under Keras libraries. So we add multiple layers. A typical neural network consists of input layer and output layer. Uh, it's sure that we can create a neural network using just input and output, but then there is no, that doesn't make any sense to have a neural network. So we have more than one, we can have more than one hidden layer. Those layers are, you can see here, there's a dense layer. Two types of layers I have used, dense and dropout. Dense layers are actual layers, actually the input, output, and training layer, hidden layer. And dropouts are for data elimination, so that we don't do overfitting. So then I have used the activations, different activation functions at different stages. I used ReLU, Sigmoid, and Softmax at three different layers. Then finally, I defined the optimizer. I have used Adam optimizer with a learning rate of 0.001. Then we also compile the model with this optimizer, and also we want to get the accuracy metrics from this model fitting. Now we define the model. Let's run this code. Now let's train the model. So in order to train the model, we have to fit the model. So this is train x. The fit function has this following argument: train x, train y, the batch size, the epochs, how many times you want to do the fittings, the validation split. Basically, we used 25%, 75%. 25% is the size of the training data. Um, so, and then if we run, this is the most time consuming part. If we run it, we will get some fits using the model. So each epoch, you can see the accuracy. So this is the training, this is the effect of training, and you see that we have run into 4 epochs. We can do multiple epochs. I have used 4 only, just for illustration. So you can see that the accuracy improves with each iteration, with each epoch. We can also do a model summary, but let's go to save the model. This is a good practice, because then I can make the code modular. I can take advantage of this saved JSON file. So I have saved it. Now comes the most interesting part, that is the prediction part. So in the prediction part, let me comment the code little bit here. So this is the prediction part. In this prediction, what we have, we still need to do tokenization. Tokenizer, we have to use the tokenizer, clean the data, whatever data we are going to predict. In this case, we are using the same data set. Then define the classes. We have two classes, positive and negative tweet. Um, and then we read the dictionary file that we have already generated. Uh, then finally, we open the JSON file, the model.json file that we just saved here. So using that model, so we run the code now. So let's test one, one tweet. This is a negative tweet from the list, and let's see what happens if we run this with the model. So let me define the model again. So I define the model, I train the model. I'm doing it all over again because there is data from my previous session. So again, you can see that gradual improvement of the accuracy with iteration. So model to JSON, then I run the prediction, and So first I put some tweet there with a known sentiment. Although it's negative sentiment, our model did predict it incorrectly. It says it's a positive sentiment with a 66% pretty low accuracy, and you can see that the predictions are not correct because we have learned from the class that model is good, like I mean data model is as good as the data. So really we need to look at the data about if there is any bias, or have we randomized the data, or we can use some data source differently, synthetic data, so that we eliminate a lot of biases. But in any case, in this exercise we can see that we have successfully successfully get a clean up the data. We have successfully built a model, ran the model, uh, train the model, uh, do the prediction. The accuracy of prediction is of course questionable, but we have to train the model in a better way. We have to adjust different parameters. But in any case, the whole framework is working. So that's what the purpose of this exercise was. So that is it for now, um, for ICP4. Thank you so much for listening.